The current concentration in the generation of power has been occasioned by the rising energy demands across the globe and awareness of climate change and pollution. Of all the potential candidates that can replace fossil fuel, biodiesel has crawled out of the pack because of its ability for being renewable, less emission, and ability to reduce dependency on conventional resources. The biodiesel made up of fatty acid methyl ester is the methyl or ethyl ester of vegetable oil or animal fats. This process biotransforms fats and oil into biodiesel and glycerol due to the catalytic action of the microorganism where biodiesel can be used in diesel engine with slight modification. The cost of raw material, particularly virgin vegetable oil, is regarded as one problem which affect biodiesel production. Therefore, there has been an increasing concern with the use of waste oil feedstock, particularly used cooking oil for biodiesel manufacturing. Used cooking oil is preferred for these three reasons. It is available, inexpensive, and can be recycled economically, making it an economic and environmental boom. In many households and industry, big amount of used cooking oil are dumped as waste and poses a threat to the environment if not properly disposed. Recycling used cooking oil for biodiesel is worth the service as well as a part of circular economy where waste material is transformed into valuable energy resources. The use of used cooking oil in production of biodiesel has a great advantages over normal diesel fuel. Biodiesel is less toxic, biodegradable, and emit less pollutant like sulfur dioxide and part per million than petroleum diesel. Also, it contains a smaller amount of carbon. It is gotten from renewable resources and has a smaller environmental impact. In addition, the use of used cooking oil minimizes the conflict between food and fuel production because used cooking oil is derived from used cooking oil does not diminish the source for virgin crop which could be arguably used in producing food. But as with every good thing, there are also some drawbacks for utilizing used cooking oil as the biodiesel feedstock. They include free fatty acid water and the impurity are always present in the feedstock of used cooking oil, which affect the efficiency of the transesterification process and the quality of the biodiesel produced. As a result, pre-treatment of used cooking oil is essential before it affects to biodiesel production process due to presence of impurity and high FFA level. Similarity choice of proper catalyst and reaction condition is strongly recommended for high yield and better quality of biodiesel. This lab report focuses the synthesis of biodiesel from used cooking oil by the process of transesterification and the experiment of using used cooking oil as feedstock, which will seek to determine the viability of producing the biodiesel from the feedstock, as well as identifying oil quality, optimal reaction condition, and biodiesel yield. This study has proved the waste oil can be used as feedstock for the production of renewable energy with improved technology while minimizing wastage. In fact, this experiment aimed at testing the feasibility of using cooking oil as a source of biodiesel to support the effort towards the increase of renewable energy sources.
Yes, Assalamualaikum. My name is Muhammad Adili Kamili Bikamsani. Today I want to present about tool and materials. Okay, tool and material use 500 used cooking oil, 4 gram sodium hydroxide, 100 to methanol, hot plate mixer, beaker L's, thermometer, Scotch bottle, magnetic steerer, digital scale, separating funnel, aluminum foil, close filter. Okay. For the safety lab, uh, safety lab use glove, masker, lab coat, and gloves lab. Okay, next is material. Okay, next is method. Day 1, put a 4 gram of sodium hydroxide on aluminum foil, then take 100 of methanol and mix. Stay for 3 minutes until the mixture becomes sodium methoxide. Next, filter the used oil with a closed filter, then heat the oil up to a temperature of 15 to 16 degrees Celsius. Measure the temperature with a thermometer. After After the temperature reach 15 degrees Celsius, add the sodium methoxide mixture and use a magnetic stirrer to stir the mixture for up to 13 minutes. After 30 minutes, put the mixture into the separating funnel and use the retort stand to hold the separated funnel. And that times you will start to see the separating process wait up to 20 hours. Next, day 2. After 20 hours, you will see the separating between biodiesel and glycerol. Put the biodiesel into the beaker, accept the glycerol. Then heat the tap water up to 15 degrees Celsius. After the tap water is hot, put a little biodiesel into the beaker and add the hot water to mix the biodiesel with the water and turn the beakers until the water and biodiesel separates. After the separation occurred, use a pipette to separate the biodiesel from the water and put the biodiesel into another beaker. Then heat the biodiesel up to 100 degrees Celsius so that the water in the biodiesel is dry. After the biodiesel reaches 100 degrees Celsius, use candles and curtain to burn the biodiesel. Okay, thank you and bye.
Assalamualaikum and good night. My name is Muhammad Fahmi bin Azizan. My matrix number is J22A0294. Today, I will present for my group result for biodiesel experiment. From the photo, we can see that in the separating funnel, there is a substance on the top of the oil on the funnel. The substance is a very jelly-like and not solidified. Different from the bottom layer of the funnel that has been solidified. After 24 hours, we pour the oil into the beaker while separating the jelly-like substance using a cloth. Using a cloth, and then we wash the oil using the water and to purify it. We done it 3 times, and after that we went to heat the oil to around 80 degrees Celsius. After that, we try to burn it. From the video, we can see that our oil succeeded in purifying. Our group succeed in purifying the oil and lost it. Thanks. That's all from me. Thank you.
And for the discussion part, our group is successful create the biodiesel as it ignite when it burns, but there are few weakness in the method that can fix to produce the better result. First, the sodium hydroxide that our group is lose the effectiveness. This is because our group oil was initially too high as it hit almost 70 degrees Celsius. When we try to add the methanol sodium hydroxide mixture or sodium hydroxide, this is resulting us need to wait for the oil to go back to desired temperature, that is 55 degrees Celsius to 60 degrees Celsius. By wait for the oil to be cool, the sodium hydroxide lose the effectiveness over time, as the effectiveness of sodium hydroxide is related to the time, and the less effective sodium hydroxide solution they add in the solution decrease the yield of the biodiesel production, and also make the presence of the impurity is increased. Secondly, the inconsistent temperature. This is our group biggest weakness, as the temperature of oil when the process of the stir the oil is not consistent, as the temperature go up and down during the stirring process. As also at the one point of the stirring process, the temperature of the heated used oil mixed with the sodium hydroxide hit 63 degrees Celsius, as this is not good, as it almost hit the methanol boiling point, that is 64.7 degrees Celsius. Because of our group for failing to keep the inconsistent heat throughout the experiment, our biodiesel is mixed with glycerin in agar-like texture, as the process of the separation happened poorly. Thirdly, our problem in our group method is oversteer the solution. Our group hot plate mixer did not function properly during the experiment, as the lowest rate of the stir rate in the apparatus is at level 3, as this make the heated or sodium methoxide solution stir at a faster rate compared to the other group, as this lead to incomplete separation of glycerin and biodiesel. For this experiment, the ideal product is to have two layer. One, to have two layer in the biodiesel. One layer is the glycerin that is sticking in the bottom of the separating funnel, and the other layer is the biodiesel that rests on the top of the separating funnel due to the different buoyancy, different density. But because the oversteer happened, this is affect the separation process, make the mixing of the both distillate, make the biodiesel solution mix up with the glycerin. As this is make the solution need more time and effort to achieve the ideal product that we desire as the two layer of the solution. And the oversteer solution make the temperature increase easily too. Well, because of the glycerin and the biodiesel not separated properly, before the cleaning process, our group used the washcloth to filter the biodiesel solution. As the product have the agar-like texture of glycerin in the biodiesel, we successfully filtered it using the washcloth. And for our group, final biodiesel product, it has a light color compared to other group. But this is the expected outcome from our group, as we use the not heavily used oil. As the oil just has been used once and not heavily. And for lastly, our biodiesel produce the black smoke when we try it. It not produce like the heavy black smoke, but there is a hint of the black smoke in the product. So we success create the biodiesel, but because it produced the smoke, it's suggesting that our biodiesel contain the impurities. And for the solution of it, we need more frequent to do the washing process so we can clean up all the impurities. In conclusion, while our group is successfully produce the biodiesel, our group can produce better result if we improve our temperature control and make sure the time of adding the sodium hydroxide is right. And if the apparatus like hot plate mixer work more properly, we also can fix few more problem in our group biodiesel. As the black smokes show that our group biodiesel need more washing process to produce more cleaner biodiesel. As all these adjustments can make our group biodiesel better. But for the experiment, we successfully create the biodiesel.
Hello, I'm going to answer the 3 questions from the lab experiment. First question is, which layer consists of biodiesel and how do you recognize it? Biodiesel from the top layer during production form expired cooking oil. It lighter and clearer than glycerol, which sink to the bottom. The biodiesel layer is also slightly darker and more viscous. The second question is how to prove the consist of biodiesel. The answer is by test by burning a small sample using the carton. Biodiesel burn with a clean bright flame and produce less smoke compared to the glycerol, confirming its presence. And lastly, what is the reaction and process involved between mixture of methanol, sodium hydroxide and used cooking oil in the biodiesel? Methanol mixed with the sodium hydroxide creates sodium methoxide, which react in the used cooking oil. This transferication process converts triglyceride into biodiesel, or methyl ester and glycerol. 2 layers form, which is biodiesel on top and the glycerol below. Thank you.